Good morning. This is Abhishek Singh. I'm a software developer and IT researcher. I live in 39 Pleasant Street, C7 Northborough, MA, USA. First of all, thank you very much, CITSM, um, International Conference on Cyber and IT Service Management, to providing us such an opportunity to submit our research paper. My research paper title is WSN-IoT, Clustering for Secure Data Transmission in e-health sector using green computing strategy. There are other few associates who has helped me to complete this research paper. Their names are Rag Srivastava, Sushil George, Joseph M. Rajkumar, Yogini Dilip, Murele, and Hari Kumar Singh. The energy has been one of the most crucial elements for 21st century. Nowadays, there has been extensive use of electronics and large computing tools everywhere to simplify day-to-day work. The crisis and non-availability of electricity at all the time have popularized and mainstreamed green computing algorithm concept for wide-scale multidimensional application. The author have made an attempt to use green computing technique to neutralize crisis hour due to medical emergencies. Wireless sensor network, which is WSN, comprises of many sensor nodes, that is SN, that are interconnected with the Internet of Things and plays an essential role in a variety of applications. IoT connects physical object as sensors to create a network for dynamic information exchange. The Internet of Things has been utilized in a variety of fields. Patients in the crisis scenario are using wearable medical sensors to check medical parameters. This medical sensor is powered by batteries and has a limited amount of energy. As a result, increasing network lifespan is a significant challenge. In order to efficiently deal with the contemporary challenge, a new novel method called resource efficient Gaussian process regressive Jarvik-Patrick clustering has been proposed to extend network lifespan. This system works on the principle of green computing technologies, which is the need of the hour. Initially, IoT devices are employed in SN to sense and gather patient data. Following the data gathering procedure, SN is classified into several clusters using a Jarvis-Patrick clustering algorithm. Jarvis-Patrick clustering is a graph-based clustering method that uses the Gaussian process regression function to divide SN. The regression function examines the SN and conduct the clustering procedure based on the predicted energy and bandwidth. Following the clustering procedure, a cluster head, which is CH, is chosen to improve data transfer and reduce latency. The data collected by the source node is sent to CH. Then using the time of flight techniques, CH located to the closest CH. Following that, data is sent from the source node to the sync node through the cluster head. In this manner, WSN perform resource efficient data transfer. Numerical studies show that the REGPR-JPC method effectively increases patient data, packet transmission potential, and reliability while minimizing loss rate and delay. So, WSN is a combination of SN and IoT. IoT connects physical devices to create a network for exchanging data. In WSN monitoring With IoT deployed, is responsible for sensing and observing data from ambient conditions and transmitting it the base station. The network guarantees data loss, which waste bandwidth and long distance transmission results in energy saving. Because of low battery capacity, SN has energy constraints. As a result, clustering is a popular technique for achieving efficient transmission in WSN. Proposed a priority based energy efficient routing protocol, which is known as a PERP, to improve data transmission dependability. However, during the healthcare data transfer, the data transmission latency was not reduced. To prolong the network lifespan, developed an effective data transmission method. However, the technique failed to decrease energy use significantly. In a, fog-assisted computational efficient wearable sensor network, which is FCEWSN, for health monitoring was created. Higher data delivery, on the other hand, was not accomplished, presented high quality clustering and CH selection using fuzzy logic of minimize the total energy. However, the algorithm was unable to cope with the increased density of nodes. In a CH selection method was developed to reduce a substantial amount of energy computation. The delivery ratio performance, on the other hand, did not increase. A cluster-based routing system that is energy aware improves the pocket delivery ratio. The delay, however, was not reduced, suggested a dynamic clustering based technique to improve data packet delivery. Although the proposed technique improves throughout, the loss rate was not reduced. To reduce the energy usage, developed a scalable and energy efficient routing protocol. However, the protocol as proposed failed to provide the greater data transmission with little latency. In a new routing system was proposed to increase the network lifespan and reduce the energy usage. However, the cluster-based routing was not used to reduce the latency. Pioneered several energy-efficient methods for IoT-based heterogeneous wireless nodes. However, the proposed method did not take advantage of various resources for data transmission. To resolve the above said issues, a novel REGPR-JPC technique is introduced. The proposed REGPR-JPC technique highlights the following primary contributions to improve a reliable data transmission. RJPC technique is developed based on energy and bandwidth consumption. The contribution is achieved based on the Jarvis-Patrick clustering and Gaussian process regression to enhance data delivery and lessen packet loss. Gaussian process regressive Jarvis-Patrick clustering is introduced. At first, the IoT devices are used in SN to collect patient data. SN is divided into energy and bandwidth. Jarvis-Patrick clustering uses the Gaussian process regression to improve the clustering accuracy. The REGPR-JPC technique uses the time of flight method to choose neighboring CH for the efficient transmission to minimize the delay. Finally, simulation was performed to compare the REGPR-JPC technique with conventional method based on different metrics. The orientation of the paper has been done in systematic order to provide a clear understanding to all the readers. The remaining section of the paper are arranged into various sections as below. Here are two. Section 2 provides literature in energy efficient data transmission in WSN. Section 3 offered an architecture of the REGPR JPC technique and described it in detail. In the section 4, simulation are performed with the medical data set. In section 5, the performance of proposed and existing method is presented with diverse metrics. Section 5 concludes the articles. So I can go through with um, the research paper to see that one, but before that, I would like to just go what we are going to conclude with this paper. And then I will go through with our research paper. The healthcare system is one of the most complex and slowly progressive sector due to lack of technological modernization. Adopting state-of-art cutting-edge tool and incorporating its existing infrastructure can trigger its efficiency to the next level. Green computing, along with scientific applications, may prove beneficial and transform the entire sector. The author has attempted to develop and introduce an all new novel REGP model for resource efficient and reliable data transfer in healthcare by green computing strategy. The whole network is first partitioned into various clusters depending on node residual energy and bandwidth uses. With the assistance of Gaussian process regression, the Jarvik-Patrick clustering method is used to group the SN. The, the regression examine the SN as well as the resource uses. Following that, the CH is selected based on a greater residual energy and lower bandwidth use to improve the data transmission. The time of flight technique is then used to locate the nearest CH for reliable data transfer from source to sink node. The simulation software is used to access the effectiveness of our RGPC methods, and the suggested RJPC method are then compared to traditional procedure, and the RAJP methods leads to increased network lifespan, improved delivery ratio, throughput, and decreased delay and latency and loss rate. And without these references, we are not able to complete the job. So these are the important references for this research paper. Thank you. And before going to close, I would like to share my research paper. This is the research paper which we are submitting in CITSM 2021. Submission date is this one, submitted by Abhishek Singh. These are the topic of my paper. These are the other contributors, few other emails, and the abstract system, the introduction of this research paper, the latency survey and methodology. There are the various issues which we are resolving with the help of RJPC technique, and these are the ways to do it. These are the algorithms which has used in this one. And there is a test result, and then we will conclude it. And there is a huge number of references for that paper. So that's it. Thank you very much.